In just 3 days, the interstellar object 3I Atlas vanishes behind the Sun, absorbing 33 gigawatts of solar power. This 7-mile object defies physics: 4% water, an anti-tail, and a trajectory that scores 4 on the definitely technological scale. Planetary defense protocols are active. Behind the Sun, the object will execute its most critical moment. Will its trajectory hold, or will a single maneuver redefine humanity? In exactly 3 days, the interstellar object 3I Atlas reaches perihelion, its closest approach to our Sun, where it will absorb 33 gigawatts of solar radiation while completely hidden from our telescopes. This third confirmed visitor from beyond our solar system has already broken multiple scientific precedents, and what happens during this solar blackout could fundamentally change our understanding of interstellar objects. Right now, as you hear these words, Atlas sits behind the Sun in solar conjunction, invisible to every telescope on Earth and in space. 5 days ago, on October 21st, it positioned itself on the exact opposite side of our star, beginning a blackout period that continues through its most energetic moment on October 29th. At perihelion, the object will experience radiation equivalent to 1/3 of all United States nuclear reactors combined, concentrated on a single body just 1.35 astronomical units from the Sun. Harvard astronomer Avi Loeb issued a stark warning about this date. If you want to take a vacation, take it before October 29th, because who knows what will happen. These aren't abstract predictions anymore. They're about processes unfolding behind our star at this exact moment, during the only window when we cannot observe them. The timing raises immediate questions. Why does this specific object, with all its documented anomalies, pass through maximum solar energy precisely when we're blind to it? The statistical probability makes this either an extraordinary coincidence or something more fundamental about how interstellar objects behave. Atlas has systematically broken every established pattern for interstellar visitors since its discovery. Its orbital alignment sits just 5 degrees from the ecliptic plane, the disk where all planets orbit. For an object arriving from interstellar space, the probability of this happening randomly is only 0.2%. This isn't just unusual, it's the ideal trajectory for accessing multiple planets with minimum energy expenditure. If you were designing a mission to visit Mars, Venus, Earth, and Jupiter in a single pass, you would choose exactly this path. The chemical signature defies natural explanation. Spectroscopic data from the Keck 2 telescope revealed nickel emissions in proportions never seen in natural comets. On Earth, this specific signature only appears in highly controlled industrial processes, specifically in alloy production through the carbonyl process. The nickel concentrates in a 600-kilometer region of the nucleus, while cyanide extends for 840 kilometers. If both were naturally sublimating from ice, they should follow similar patterns based on volatility and solar heating. They don't. Atlas contains only 4% water by mass. This revolutionizes our understanding of what interstellar comets can be. Comets are essentially dirty ice. Water should dominate their composition. Borisov, the previous interstellar comet that everyone agrees is natural, had typical aqueous composition. Why is Atlas fundamentally different? The polarization of light reflected by Atlas is extremely negative, a phenomenon never observed in known comets, including Borisov. This suggests unique surface or structural properties that we don't understand. The object's mass reaches 33 billion tons, 1,000 times more massive than Borisov, 1 million times larger than Oumuamua. With a minimum diameter of 5 kilometers, it possesses sufficient mass to carry significant payloads through interstellar space while maintaining structural integrity. Between July and August, Atlas developed an anti-tail, material ejected toward our Sun contrary to normal cometary behavior. Analysis confirmed this isn't a perspective illusion. Material was genuinely being ejected against solar radiation pressure, suggesting active internal energetic processes that shouldn't exist in a passive ice ball. Loeb created an evaluation scale from 0 to 10 for potentially artificial interstellar objects. Atlas scores 4, not conclusive, but significant enough to justify serious investigation using planetary defense resources. And that's exactly what's happening. For the first time in history, protocols normally reserved for extinction threats have been activated for an object that cannot directly impact Earth. The International Asteroid Warning Network, created specifically to detect and track civilization-threatening objects, initiated an intensive 3-month monitoring campaign for Atlas. The campaign began on October 27th, 2 days before perihelion, and will continue until January 2026. This is unprecedented. The network doesn't waste resources on scientifically interesting objects. They exist to prevent extinction events. The decision was made based on pre-perihelion data, suggesting the documented anomalies were sufficient to justify treatment as a potential threat. But Atlas is not on a collision course. Its maximum approach will be 1.8 astronomical units from Earth, farther than Mars. There's no physical possibility of impact, so why activate planetary defense protocols? NASA captured the highest resolution images of Atlas on October 3rd, when the Mars Reconnaissance Orbiter photographed the object passing 190 million kilometers from Mars. The high-rise camera achieved 30 centimeters per pixel resolution at that distance, 3 times better than the best Hubble images. These photographs remain unreleased. Loeb has publicly requested access repeatedly through blog posts and direct emails to NASA. The silence in response is conspicuous, especially considering these are the most detailed photographs of the object in existence. In stark contrast, the European Space Agency has been relatively transparent. The ExoMars Trace Gas Orbiter imaged Atlas and released data showing classic comet appearance, a diffuse point with small tail. Reassuring until you examine the spectroscopic analysis of the same data, which reveals the anomalous chemistry. Physics allows multiple explanations for Atlas's behavior, each with profound implications. The exotic natural comet scenario suggests Atlas formed under radically different conditions from our solar system. Other stellar systems have different metallicities, distinct formation temperatures, chemical processes that don't occur here. The nickel emissions could result from natural carbonyl processes in the nucleus, spontaneous chemical reactions under specific temperature and pressure conditions. The low water concentration suggests formation in a volatile pore region, perhaps near a young hot star. This scenario explains the chemical anomalies, but struggles with orbital alignment and perfect timing. The controlled fragmentation hypothesis proposes the object may be disintegrating in a highly organized manner, releasing internal components with distinct physical and chemical properties. This would explain the anomalous emissions and composition variations. Fragmentation could be triggered by increasing solar heating approaching perihelion. Internal structures preserved for millions of years in interstellar cold begin to sublimate or react chemically when exposed to intense solar radiation. The active orbital maneuver possibility is the most testable. If some process alters Atlas's velocity during perihelion, we would see measurable orbital changes in the following weeks. A deceleration of just a few meters per second would be sufficient to keep the object permanently in the solar system. Perihelion offers the ideal energetic window for such maneuvers. It's the moment of maximum orbital velocity, when any applied impulse is amplified by orbital mechanics through the Oberth effect, used by all interplanetary missions. The ejection scenario considers that Atlas may release fragments or smaller components during maximum perihelion heating. With its estimated mass of 33 billion tons, it could eject thousands of smaller objects and still maintain structural integrity. This would explain some anomalous observations while remaining within known physics. The astronomical community is deeply divided about Atlas, reflecting fundamental tensions about how science should address anomalies and uncertainties. Jason Wright, astronomer at Penn State, published one of the most devastating critiques of Loeb's work in a blog post titled simply Avi and Atlas. Wright systematically challenges each proposed anomaly. On the supposed absence of coma, Wright argues that Loeb misinterpreted how telescope tracking works. When you track a moving comet, you keep the nucleus sharp while the background blurs. Of course, you don't see diffuse coma clearly in this imaging mode. On size calculations, Wright contests that Loeb assumed asteroid albedo, 5% reflectivity, to maximize size estimates. If Atlas is a comet, it would have a smaller nucleus surrounded by bright coma, not the giant mass Loeb calculates. Loeb responds that his critics are so invested in conventional explanations that they reflexively dismiss anomalous evidence. He argues that science has a conservatism problem. Paradigm shifts are resisted. Outsider ideas are dismissed too quickly. Wright accuses Loeb of bypassing peer review, publishing directly in blogs and interviews before submitting formal papers. Loeb responds that the peer review system is too slow for transient phenomena. Atlas won't wait months for editorial committees to deliberate. Betting markets currently place odds at 75% natural comet, 25% artificial origin. These aren't scientific probabilities, they're aggregated human judgments reflecting the deep uncertainty unfolding in real time. The coming months offer 3 distinct opportunities to resolve the Atlas mystery definitively. November 4th brings the JWST flyby. The European Space Agency's JWST probe will make the first post-Perihelion observation, passing 64 million kilometers from Atlas. This will be our first opportunity to see how the object changed after exposure to 33 gigawatts of solar radiation. If Atlas executed a maneuver during perihelion, the effects will be obvious in JWST's data. Velocity changes of just meters per second will be measurable. December 19th marks maximum Earth approach. Atlas will pass 1.8 astronomical units from Earth. All major ground-based observatories will be directed at the object. The James Webb Space Telescope will be able to detect thermal signatures and molecular composition in extraordinary resolution. This represents our best opportunity for comprehensive analysis with our most advanced instruments. March 16, 2025 brings the Jupiter encounter. Atlas will pass 54 million kilometers from Jupiter with NASA's Juno probe, providing frontline observations. If the object released smaller components during perihelion, some may be on trajectories that bring them near Jupiter at this time. Each window builds upon the previous one, creating a progressive revelation of Atlas's true nature. The central question is elegantly simple. Will Atlas's trajectory change? If the object follows pure gravitational laws, we'll confirm that interstellar comets can have surprisingly diverse properties. We'll learn about formation processes in other stellar systems, about how different chemical environments produce objects with unique characteristics. Science will advance incrementally but importantly. If orbital deviations appear, if non-gravitational accelerations are detected, if multiple components emerge where we expected only one, we'll face a new type of phenomenon. Not necessarily artificial, but definitely something outside our previous experience. The implications would ripple through astronomy, astrobiology, and our understanding of interstellar space. The beauty of science is that nature always has the final word. Atlas is about to provide that reality test in a way few scientific discoveries can. The data won't lie. The measurements won't equivocate. Either the object behaves according to known physics, or it doesn't. The blackout ends in November. Telescopes around the world will reacquire the object. The first post-Perihelion data will arrive from the JWST spacecraft. Then, we'll know if we're observing exotic chemistry from another stellar system or something that defies current categorization. Regardless of the outcome, Atlas has already expanded our perspective. It has forced us to question assumptions about what interstellar objects can be, how they behave, what processes they undergo. It has revealed gaps in our knowledge about the cosmos we thought we understood. It has shown that even with our advanced telescopes and sophisticated models, the universe can still surprise us. In 3 days, processes that may redefine our understanding of interstellar objects will be occurring behind our star, invisible and undetectable. The energy of 33 gigawatts will interact with an object carrying mysteries from another stellar system, perhaps triggering changes we can't predict. In 3 weeks, we'll begin to see the results. The waiting has already begun.